Okay, that's it. Okay. Hi, my name is Philipp. I work for a company called Sentry. We do application monitoring for many different platforms, also including iOS and macOS, of course. I work there as a senior mobile SDK engineer, taking care mostly of the Cocoa SDK. So let's get started. Developers need a fast, reliable CI to be productive. An excellent CI helps you to find issues in your code and confidently ship new code and reduce the stress. But setting it up properly is difficult and takes a lot of time. This talk is not about showing you how to set up a CI from scratch. Instead, I'll share some advanced tips and tricks we use in our open source project of the Cocoa SDK. It's important to note that some of these tips and tricks might work for you and others might not work for you because it's an Cocoa SDK library that people can use in their iOS application or macOS application. Just a short overview of what I'm going to cover in this session. We're going to have a look at test logs, flaky tests, how to deal with flaky CI, Swift-lint, C-lang format, Xcode Thread Sanitizer, Xcode Analyze, how you can validate your library, that it's compiling properly, a little bit of a weird technique called borrowing tests from other repositories, and in the end, high-risk files. So you will see what all this mean in a couple of minutes. So without any further ado, it's time to level up your CI. So the first topic is better test logs. So if you invoking Xcode build from the command line, as you would also do it in CI, there's a lot of information, and if a test fails, you have to do a lot of scrolling until you actually find the failing test explaining you what happened and went wrong. There's a pretty cool tool called Xcode that you can install. I guess many of you already heard about it. After you install it, all you need to do is you just have Xcode build with all your build flags and test invocations. And after that, you just append this on the command line and it will make the test log output way cleaner, and it directly tells you what went wrong. And you can see which test failed at a glance, and you don't have to do all of that scrolling. Just for information, Fastlane uses this tool under the hood. If you never heard about Fastlane, I strongly recommend Googling it afterwards. But sometimes this raw test output log files and this test output log is very useful if the Xcode just maybe hides some detail. So what I like to do is when in CI, when I have this simplified test output log, I actually use the T command to first put all the raw test output into a file and then forwarding it to Xcode. And then I can use the log file and store it as an artifact in GitHub Actions only if the tests fail. We at Sentry use GitHub Actions, but I think like Bitrise or any other cloud CI provider has a similar concept of artifacts. Maybe they call it attachments. I'm not sure, but I think everyone has a similar concept. Another thing that can help you to investigate why your tests are failing and get a better understanding are the derived data logs. The derived data is actually a folder inside Xcode where Xcode stores all kinds of intermediate build results, generated indexes, whatever, but it also stores test results. And how you can archive this is you just have to find the folder, the path of Xcode, and you just look for your project, and if the tests are failing again, you can upload them as an artifact, and then you can download it when the tests are failing from CI. And what I mentioned already previously is you can have a look at the Xcode test results, which then you can open up in Xcode. It gives you insight on which tests are failing. Also, you get an overview of the whole test suite. And it sometimes contains useful information that helps you to understand why a test failed in CI. Okay, that was better test log. So using Xcode, attaching the raw test output log and also the derived data logs. The next thing I want to cover is flaky tests. I mean, flaky tests can be pretty annoying, especially if the tests are only failing in CI. And that can be, of course, like CI usually has a different environment, a virtualized environment. You have less CPU cores available than if you would have, for example, a powerful M1 machine. So what I do first, if a test only fails in CI, is that I try to reduce it locally. And a simple thing that you can do is you run the tests repeatedly. And what you should not do is just go in Xcode and click again on one single test and run it repeatedly. No, if you right click on this run button actually, and many people don't notice, you can actually run the test repeatedly. You just click on this one and then it opens up a window and you can say, hey, I want that this test runs 100 times in a row. And this could already uncover a flaky test and telling you what's happening. You can reproduce it locally. And also what you can do is you can do this actually on the whole test suite. So if you have some global state that could be maybe leading to some flaky tests in CI, that also helps maybe to reproduce it locally. If repeated tests run are not happening, there's something pretty cool from Xcode Test framework that's called the Xcode Test Observation Center. And you can just add a test observer. And the test observer just needs to implement the Xcode Test Observation Protocol. And then you can subscribe to many different events. And one of these is the test case if it records an issue, basically if a test case fails. And what we do in our specific repository is we just create an exception and capture this to our error monitoring tool, Sentry. We also add some breadcrumbs along the way. So whenever a test case starts, we collect some breadcrumbs. And then whenever we capture test failure, we see in the error reporting tool which tests were executed before this certain test. Again, this can be useful if you have maybe some global state. And then I can have a look at that in Sentry. I can just see all the tests that are failing. And it also gives me data around on which machines it happened most often. This one just happened on macOS, so maybe the test only fails on macOS. Some CI providers, I think, already do like give you statistics out of the box if you use a certain format. But if the CI provider doesn't do that, or if you want to add your own context, you can maybe use this. And of course, you don't have to use Sentry. You can use whatever crash reporting tool or issue reporting tool you have. The next thing is if you actually fixed your flaky test, you think you fixed it and it only fails in CI, what some people do is they just say, hey, let's merge this and wait on the master branch, on the main branch, if it starts happening again. And then, I don't know, after 30 commits, it maybe is flaky again. And I think like, hey, that's a waste of time. Why can't we just use CI for validation? Again, this is from GitHub Actions, but I think every CI provider should have a similar concept. There's a concept that's called a build matrix, and I just want to have like two different parameters, and I want CI to run all the different possible combinations of those two parameters. In this case, it would just be iPhone with the different iOS versions and iPad with the iPadOS versions. And who says that I have to do something meaningful with those values? I can also create a dummy matrix, just 1 to up to 5. And this will then run my test job, my test build 25 times in CI, helping me to get a better understanding if my fix actually fixed the flaky test. Okay, this was about flaky tests. Run them repeatedly, use the Xcode Test Observation Center, and using a dummy matrix. The next thing I would like to cover is flaky CI. First of all, CI shouldn't be flaky. Most of the time it isn't. Usually it's your tests or how you use certain tools. But if some command in CI is flaky, not CI itself, but something that's like, it's really hard to control, what you can do is you can use the simple bash for loop, which only fails if the flaky command fails 5 times in a row in that certain case. And with that, you can kind of fix flaky CI for you, only if it fails 5 times in a row. The next topic I'm just going to point out is SwiftLint and CLang format. Those are two pretty cool code formatting and linting tools. If you never heard about these, just Google them after the session. I'm going to just share the slides anyway. They're pretty easy to set up, but I don't have time now to go into detail for those two tools. So instead, I'm going to focus on the Xcode Thread Sanitizer. That's a powerful tool in Xcode that can help you to uncover threading issues. So let's take a simple Swift code example. I have a very, very simple class that's called counter. It has one method increment and a property computed that returns the current count. It has an internal count. It's a very simple logic, but let's assume I want to call this from multiple threads at the same time. Obviously, this code is not thread safe, but let's write a test for this. I want to just test the increment concurrently. I want to run this 100 times. I use a dispatch queue and I just asynchronously increment this 100 times, and it could actually be that the test succeeds because due to an internal dispatch queue logic, it can actually be that they don't run in parallel, whatever, like the result is not really deterministic, but it could be that the test succeeds. How you can already uncover this threading issue is if you go to your test schema and you click on the diagnostic tabs and you check this checkbox Thread Sanitizer and you run the tests again, Xcode will already tell you that it found a data race at that specific location. But now let's have a look at how we can run this in CI. This is pretty simple. You again have your Xcode build with all your flags and the test command, and you just need to pass in this specific flag, and then the Thread Sanitizer will run. Then in the log output, if we see that if you run that on the command line or in CI, it already tells me that it found a data race, points me to the specific location. But the problem is that this job would actually succeed because the test succeeded. So I want CI to fail if the Xcode Thread Sanitizer finds a threading issue. So all I need to do, how can I make this work, is I again just store all the log output to my Thread Sanitizer log file, and then I just do a simple search in this log file if there is this warning Thread Sanitizer. If I find it, I say Xcode 1, letting the job fail, also giving a short message on how to solve the problem, and otherwise I just say, hey, I didn't find any problems and everything is fine. Just worth mentioning that the Thread Sanitizer adds a big overhead to your code, so maybe it's not the best idea if you have a test matrix running on different operating system versions that you run this for everyone, because it will drastically slow down your CI. Okay, that was Xcode Thread Sanitizer. Now let's have a look at Xcode Analyze. That's a powerful static code analyzer that works for Objective-C, C, and C++ code. So why am I even mentioning this? We write new code, of course, usually in Swift if you write an iOS application, but maybe you have some legacy code that has Objective-C or some other code that is C and C++. And this code, if you never wrote Objective-C code, it's pretty easy to get it wrong. And it's just good for you to help something that tells you if there are any bugs. In this Objective-C code, there's a critical bug, actually. I'm not going to tell you exactly what it is, but if I would now go to Xcode Analyze, it will tell me what the problem is. But again, let's have a look how I can call this from the command line. I just, instead of, for example, using a test command, I just replace it with the analyze command with the same build flags. Xcbeautify even supports that. And if I run it, it shows me what the error is. But the problem again here is that the task succeeds. Okay, hey, the analyze succeeded, but actually, again, I want CI to fail. So how can I do that? I do this by just creating an HTML report, passing in this flag. And I also tell Xcode, instead of storing it in this local private location, that it should store the analyzer output in a local directory called analyzer. And then I just search in the analyzer if there is an HTML report, because the analyze tool will only create an HTML report if it finds any errors. And that specific shell syntax will then call like Xcode 1 if it finds anything. And if it doesn't, it will just call Xcode 0. So now this will fail in CI and will tell me exactly what the problem is. Just a sip of water. The next topic is validating your libraries. So You should actually validate your library by using some unit integration tests or whatever to validate the functionality. But you should also validate that your library properly compiles. The easiest one is CocoaPods, because CocoaPods has this pod lib lint command, and it just checks if your library can be compiled with CocoaPods. For us, this took around 12 minutes, and I recently just found out that I can use this platforms flag to specify which platform I want to validate CocoaPods for. Previously, it was validating all 4 different platforms sequentially. And with this, I can run them actually in parallel in CI, which speeds up my job to 3 minutes. It's a pretty nice improvement. The next thing is Swift Package Manager. Still, as far as I know, there is no Swift Package Manager liblint or something. So how we validate that our library properly compiles is by just adding a simple sample application. It's a command line application that almost does nothing, and it just points in our code repository, it just points to the main branch. But in CI, I don't want to point to the main branch. I actually want to test it with the current commit hash of the pull request or the branch I'm currently running CI for. So how can I do this? I just use the set command, simple find and replace tool on the command line. I search for the main branch and I just replace it with the current commit hash. Again, for your CI provider, this might be a different environment variable, but I'm sure it would work. And I just run it over the package.swift file, and this replaces the main branch with the current git commit hash. And after that, all I need to do is run Swift build, and it will just pull my current repository and just resolve it normally as any other developer using my library would resolve the dependency and make sure it properly compiles. If you're using Carthage, the approach is pretty similar. If you use a simple card file, you can use, again, the set command to make it work. If you are using pre-built exe frameworks or frameworks, and you ship them with your releases on GitHub, that's a little bit more complex. So if you are interested in how to achieve this, I share the slides afterwards. You can click on this link and it will lead you to the location how we do this in CI, because this maybe explaining this could take up, I don't know, 5 minutes, and that's just not, I don't have time for this right now. But it's worth mentioning. Okay, now you know how you can validate your libraries in CI, Swift Package Manager, CocoaPods, and Carthage. Now let's take a look at a little bit of, I would say, maybe weird technique that is, I call boring tests. So our SDK hooks into UI view controllers, NSURL session, and a couple of other things to be able to instrument the performance of an application. And it's a little bit dangerous what we do, but it works. But we could easily break core functionalities of those mentioned frameworks. So instead of writing a huge test suite to test every different possible scenario of UI view controllers, what we did just was like, hey, why don't we just borrow the tests from other open source projects, add our library during the tests, and just run the tests and see if they're succeeding. So how do we do this? We just clone the other repository, we add the library to the tests, and we point again to the Git master branch, the main branch. And after we did this, we create a Git patch file. And in this patch file that I'm then going to commit into my local repository of the Sentry SDK, I just add a reversion placeholder that I'm then going to replace again with the Git commit hash of the current commit that I run CI for. So in CI, what you need to do is, instead of checking out your local repository, you would check out the other repository, a specific commit hash, because if maybe they merge a flaky test to master, I don't want my CI to fail. Then I use the curl command to just download my single patch file from my repository, because like I cannot check out both repositories, and copying over files is just taking way too long. So I just download it. And then I use the find and replace command again to replace it with the current git commit hash. And then I just apply the patch and run their tests as they also are doing in CI. And with that, I know that my current library version is not messing up any core functionalities that those unit tests and integration tests are actually testing. The final topic I'm going to touch is high-risk files. So what are high-risk files? So for me, that are files that are really hard to test, and if you change them by accident, they can blow up real big. So what I like to do if I have a section in the code that is really hard to test and I just want to warn people, please don't change this by accident. It's bulletproof. Don't think you're smart. You can change it and improve it. For actually making sure that nobody does this by accident, including me in CI, I created a simple bash script that's called no changes in high-risk files. And all we do there is we just calculate the hash of this file and compare it with the hash of the file when we were sure that it's working properly. And if they're the same, we say, hey, everything is fine. And otherwise, we just print a warning and let the CI fail and telling you, hey, did you change this by accident? And if not, then you can come in here and change the stored hash code, and then it would be fine. That's everything, all the tips and tricks. So let's just recap. Better test logs is something that we looked at in the beginning. Xcode storing the raw test output log as an artifact, also the derived data logs. Flaky tests, you can run them repeatedly in Xcode. There's the XC test observation center that you can try, and you can also use a dummy matrix to actually let CI validate your flaky tests. You can use a simple bash for loop to run flaky CI jobs sequentially, and only if they fail, for example, 5 times in a row, you let them fail. You can check out SwiftLint and CLang format after this session. Xcode Thread Sanitizer for uncovering threading issues. You can use Xcode Analyze to find code issues in Objective-C, C, and C++ code. You know how to validate your library that it's compiling properly. We looked at a little bit awkward technique of borrowing tests from other open source repositories, and just recently how you can make sure that nobody changes high-risk files by accident. That's all. That was everything. If you're interested in checking out all the code, you can check out the Sentry Coco repository for seeing those tips in action. And with that, I have 3 minutes for questions if there are any. Let me check. So if anybody has a questions, now is the time to ask your question. Yeah, I'm also going to share the slides. Thank you, Richard. Thanks, Mateusz. Also, thank you, Kubilay, or Erdogan, I hope I pronounced the name correctly. Also, if you have any questions and they come up later, you can also go to, find me on Twitter. And also, if you go to the Sentry Coco repository, you can just reach out. You find a Discord link and you could also reach me there. A SwiftLint for our SwiftLint format. SwiftLint is, I think, for uncovering coding issues, and SwiftLint format, I think, is just for formatting code. But as far as I know, SwiftLint also formats your code, but I would have to check this. Or maybe the other tools, both tools do the same. I'm not sure. Thanks, everyone. I think SwiftLint can format the code if you use like autocorrect or something. Should work. Yeah, if the rule supports it, yeah. So if SwiftLink can autocorrect the problem, it will do that. But if there's some things that it cannot do, like just using the bang operator or something, then I think you have to resolve it manually. Okay, with that, I think we out of time. Thank you everyone for listening. And yeah, have a great day. Thanks.